do something, calculator error, or small, I can give you partial credit. So kilograms, what goes on the bottom? And on top? All right, so what should we do from there? All right, who's bigger? I hear decagrams, so we're putting a what next to, or sorry, I heard kilograms, so we're putting a what next to kilograms? All right, and how many spaces between King Henry died by drinking chocolate milk? How many spaces between kilo and deca? There's 2 zeros and we have a 1. So when we multiply, we get what? 1,470 decagrams? Did I do that right in my head? All right, anybody not okay with that? Now, if you put it in scientific notation on the quiz, 1.47 times 10 to the third decagrams would also be fine. So either answer is acceptable. I don't care which way you wrote it on your paper. I'm good with either. Okay? All right, number 2. You have 407.8 centimeters cubed, changing it to meters cubed. What's different about this question? They're both cubed, so what do I have to do different? Cube the number. So who's bigger this time? Meters, we're putting a 1 there. How many places between meter and centimeter? All right, King Henry died by drinking chocolate milk. How many spaces between the baseline and the centime? 1, 2. So 2 zeros. And you said this time because both units were cubed, I'm cubing both numbers. All right, so when I calculate, what did I get this time? This one, I should do what? I should do what? I should do scientific notation. Because that's going to be a million. So I'm going to wind up with 0.000478 if I did it right in my head. Okay? That's a lot of zeros. So put that one in scientific notation. 4.078 times 10 to the what? Negative 4. And meter cubed. Okay? Everybody good? Yes or no? If you're not, speak up. I have no idea. What is that? Good. Cool. Yeah, Bobby. Even I don't do that one. You're welcome. All right. Number 3. What's different about number 3? Only one cube. All right. So what should stick out in our heads? If you see that on the quiz. Milliliter. So which one's a milliliter? Centimeters cubed is the same as an ml. Okay? So you're saying 3.67 liter to milliliter. Who's bigger? How many spaces between liter and milliliter? So 1, 2, 3. You get 3,670 milliliters. You can leave it like that, or 3.67 times 10 to the third milliliter. Either answer is acceptable. I will grade it either way. Question? Yes, no? You have one, just ask. All right. The next 2 require the calculator. Let's see what we have. 5.67 second EE4 times 5.21 second EE9, 2.95 times 10 to the 14th is what I got there. Anybody else get that? Yes? Well, Leah and bob her head yes, so I'm going, well, I got the right answer. Well, did you write E14? Yes, I would take off that. Because the E is just what the calculator gives you to tell you that your exponent of the 14. So you want to go ahead and write times 10 because that's the actual scientific notation. Okay, 9.53 second EE negative 12 divided by 7.43, second EE, negative 5. I got 1.28 times 10 to the negative 7. Anybody else get that? Or did I calculate it wrong? All right, let me try it again. 9.53, second EE, negative 12, divide 7.43, second EE, negative 5. That's the same thing. Then you multiply instead of divide, that'll do it. Okay? Remember, if you see one of those, that means divide. Okay? And you might not see that today. That might be on another quiz this week. That might be on a significant digit quiz. All right? The last one says find the volume of copper if you have a mass of 36.5 grams. What formula are we going to use to do that with? Density. Density equals mass over volume. All right. I need volume, so V. I gave you a mass of 36.5. What am I missing? Where do you find it? What's the density of copper? I don't know off the top of my head. It's what? 8.92. All right, so I'm going to do what to solve? I'm going to cross multiply. So 8.92V equals 36.5. All right, so to solve for V, what do I do from there? Divide by 8.92. Divide by 8.92. So 36.5 divided by 8.92, I get 4.09. And checking my unit, this one had a gram. On your reference table, what's up there at the top of that column? Grams over centimeters cubed. All right, so grams over centimeters cubed. What do they have in common? The grams. So what happens to those two grams? They cancel each other. So this is going to be what? Centimeters cubed. Question. I feel okay about what we did last Thursday and Friday. Yes? Xavier. Say what now? On which one? Tell me what you put in the calculator. No. You're keeping these numbers. And you're keeping this and this. And you put that in the calculator. You're doing 407.8 divided by this. 100 grams. If you're not actually keeping that, you're keeping 100. I don't. Well, what? Nope. All right. When the exception of April has been out for 2 days, the rest of us need a writing utensil, a calculator, and a new reference set. All right. Right now, given that y'all done that well, I'm certainly not going to recognize the handwriting, given this is the first assignment that I've taken up to you. Please write your first name and your last name on the page. Sorry. I will eventually have no trouble, most likely, recognizing your handwriting. I will certainly be able to know who you are with just your first name. But for the first couple of weeks, be ever so kind and write your first and last name. When you finish, just flip it over on your desk and wait patiently for your classmates to finish. Everybody have a place? Yep, that makes sense. So, All right, come into your stores now. Come on. I got 4 hands, 5. All right, I'll give you about another 3, 4 minutes. All right, that's their 4th. All right, fun thing. You can move on. That's a lot. You got a piece of paper here. Wow. So you can have a quick work on this paper. So grab the book, top here, pull it over the open, and then we'll go there before it gets lost. significant digits? All right, so on Friday, we talked about accuracy and precision, right? Yeah. All right, tell me what accuracy is. Okay, closest of an answer to the expected value. So, being able to get the right answer. What is precision? Mario, what is precision? The ability to reproduce it. So being able to get the same answer over and over and over again. So how are we going to be able to achieve those two things? Well, your ability to read equipment correctly is how we're going to do that. So, on Friday, I did this with my physical science folks, and about half my class looked at me when I sent them out to the counters. They're like, I don't know how to read this equipment. How many of you have never used triple beam balance in this room? Because half of them were like, where's the button to push? We only use a digital scale. They hadn't used a real triple beam balance before. So do I have anybody in here who's never used a triple beam balance before? Xavier hasn't. So we got a few. Okay. So first of all, it's okay if you haven't. I mean, I was just sort of stunned, but I guess I should expect that at this point. We only have like 2 in the whole department, so we don't use them a whole lot here. I won't give it to you at all. So let's say that we want to find the mass in my calculator. This is all you're going to use in here. Triple beam balance. So how are you going to find the mass of that calculator? So somebody who's used this before, tell me what you're going to tell your group mates to do. Which one? The big one goes first. All right, and you move it, and first of all, you got to move it until it hits the groove. Okay? It can't sit between the grooves. It has to be in a groove. And you move it until what happens? So it falls down. And that tells you it's too heavy. So you do what? Go back 1. Okay? So we know it is less than 300 grams. All right, now I move which one? Which one do you think goes small? The back one. Okay? The one that reads the 10. And you do what? You move it until what happens? Until it goes down. And that tells you again it's too what? Heavy, so go back 1. And again, it needs to fit in a groove. Now, the balancing out is the last one that reads the ones in the 10th place. So, that's going to be the pencil. This is the one you're going to slide until it balances. Okay? It's a lot easier to do this if you get down close enough that you can make some sense. All right, that's how we rate. Now, how do we write this answer to the correct significance digit? Now, you have to read everything we do in this classroom to the correct significance digit. So, first of all, what are significant digits? Significant digits are all known digits plus 1 guess. Now, the thing that gets people in trouble is the guess. People have no trouble reading the known digits. It's the guess they leave off and don't do. However, in chemistry class, you have to do the gas. So, if you did not draw the picture I just drew, I'm only recommend you draw it because you're going to need samples of these to look at some point down the road. Now, the lab that you're going to do is going to require you to read equipment to the correct significant digits. I'm going to send you out. I'm going to give you, I think it's 7 things to read the correct significant digits. Now, do I know what the beakers weigh in this room? No, I have a rough idea. However, I'm not grading your ability to get the exact mass of the beaker. I'm grading your ability to read the beaker to the correct significant digits. Do I know the beaker's mass to the correct significant digits? Absolutely. So if you read the significant digits wrong for any piece of equipment in the room, you get the wrong answer and you lose points today or tomorrow, whichever day we get to. If we don't get to number 6 today, it's right after the opening tomorrow. Okay? So you have to be able to read the equipment to the correct significant digits. So this is the triple beam balance. How do we read the equipment to the correct significant digits? Well, for those of you who've read this before, first of all, what do you do with the 3 beams? What do you do with those numbers? Add them up, okay? So when we add them up, what do we have? 261, so 200 plus 6, 260, 261, everybody with, I think that was Mario's voice I heard. All right, 261, everybody with her so far? Okay, so if this is the 1's place, that makes this the what? That makes this the 10th place. All right, so 0.1. Okay. We know it's 0.3 because it's not all the way up to the 0.4. Is everybody okay with us on that? Now, these are the known digits. That's what I typically get. If this was my physical science class, that's what I would get. Now, in chemistry class, I need the gas. You get a gas that goes here. Okay? So in your mind, you know this is 0.3 and that is 0.4, correct? So I want you to envision 0.3 and 0.4. And you can see that this is pointing at about here, right? I want you to envision numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. In your mind. Okay? Okay, because you've got to envision this. I can't write 1 through 9 between these little hash marks on the scale. It's not going to be on the scale. It's not going to be on the graduated cylinder or the thermometer. You've got to envision them in your mind. 1 through 9. If this is at the halfway point between 0.3 and 0.4, you would give it what gas? You would give it a 5 if it was at the halfway point. Is this black line or that arrow at the halfway point? I wouldn't give it a 5 then because it's not halfway. If it's greater than halfway, I would give it a guess of 6, 7, 8, or 9, depending on how far you believe it is greater than halfway. If it's almost touching the 0.4, I would probably give it a guess of what? 9. Pretty close to the 0.4, maybe an 8. Not so much, maybe a 6 or a 7. But we can tell that arrow is closer to the what? The 0.3. How close you think it is to the 0.3 is your guess. Do I get to say it's wrong? No. Okay? Now, when I look at it, does it look like it's almost halfway? No, so I might not go 4. I can see it's close to 0.3. Now, that doesn't really look like it's drawn quite to scale. But when I'm looking at it, I'm trying to give the best estimate I can. What guess would I like to give to illustrate where that black arrow is pointing beyond the 0.3? Sure. You say a 2? I put a 2 right there as my guess. Now, was that Samaria's voice I heard again? Okay, Samaria went with a 2. Tiffany, what guess would you have given? If you went with a 1, that would have been fine. Tomas, what would you have said? Okay, and that would have been your guess. Marissa, what was your guess? That's fine. Okay, if somebody had said a 3, just on the off chance that somebody did, then that would have been their guess. There's nothing wrong with picking those numbers. Okay, it's your guess. Now, what if you have a graduated cylinder? Right? Let's say we have it reading from the 30 line to the 40 line. And I put the water in it like that. Okay, put the water in it. All right. First of all, where do we always read water at in a graduated cylinder? Top, bottom, middle, what? Bottom. Remember the name? Very good, buddy. It's called the bottom of the meniscus. All right. All right. Read water at the bottom. All bottom of the meniscus. Now, this is where some of you are going to struggle a little bit because you're going to stand up nice and tall. Okay? And I'm not calling first on. All right? You're going to stand here, you're looking down and going, oh yeah. Volume is 80. Can I tell what these lines say from up here? No. You need to be way down here looking at it straight on. Okay? It's called a parallax error if you don't. You know what a parallax error is? When you see things and it's distorted. Okay? So I can see the number 80. I can see the line, but looking at it like this, I can't tell what line it is. I can see an 80 and 70 and I can see the blue line, but I can't really tell what the line says. Sort of like, got your license in Florida? Yep. Remember driving with mom, dad? Remember sitting in the passenger seat? They ever say slow down there when you were going too fast? Yeah, they were going 55. Well, they didn't know if you were over 55. They had a parallax error. They're looking over at your speedometer. They're sitting in the passenger seat. They weren't looking at it straight on. So the plastic that covers your speedometer could distort it so that they didn't know exactly what the speed was. If it's digital, you have a digital speedometer, okay? Then they might have it. But if it's a dial that goes up and down, it might have been 55, it might have been 60, it might have been 50. They weren't real sure, but it was getting close. They were probably going, Florida, slow down. Because they weren't sure because it's a parallax there. I know, this is my daughter all the time. She's like, Mom, I ain't got to 50 yet. Okay? So if you want to know what it is, you have to get down where you're looking at it straight on. Okay? Now, when you're looking at this, you're reading the bottom. Okay? So this time when you go over here, what number are we going to have? Well, this time, what is this? Is it the ones place? This is the tens place, right? So what are these numbers over here? These are the ones. Now, the reason I point this out, I go back one slide in just a second. On the balance, these numbers were the ones. So these little tick marks were the ones. They were the tenths. So if we read the tenths, tenths, the gas was in the where? Where's the gas at? Use your math skills. It was in the hundreds. Okay. So any equipment that reads tenths, the gas is going to be in the hundreds. Does that make sense? Okay. So let's look at the graduated cylinder. Do I need to wait a minute? Okay. So if we're looking at this one reads tens here. So this is the one. Okay. So what one do I know? What am I definitely past? I'm past 35. Okay, so those are my known digits. That's it. All I know is 35. So that means what? My guess is in the tens. Okay? So if I read 1, my guess is 10. So decimal guess. So this time I'm not going to draw 1 through 9. All right? You're just going to visualize it and tell me what you think. What guess would you give it? Okay? If that's what you think, then we'll put a 2 there. Anybody have anything different? Now, for me personally, talking about guesses, for me to put a 1, that green line has got to be almost down here on top of that 5 line. Okay? And it's not. So for me, I would not go with a 1. Okay? For me, it's pushing almost what? Halfway between 35 and 36. So for me, if I'm giving it a guess, I'm going 3 or 4, personally. But it's y'all's guess. You can put a 1 and I'm not marking it wrong. But I'm probably going 3 or 4. Because it's looking more halfway to me than anything. But if you want to put a 1, you can put a 1. But if I'm putting a 1, it's going to need to be more down along there for me to put a 1. Okay? And it's not that close to 35. That's why I wouldn't put a 1. But if you want to put a 1, put a 1. Does that make sense? Okay. Let's do a little practice. All right, I'm going to tell you which ones to mark out on the graduated cylinders and the thermometer, because we don't have some of this equipment, so we're not going to play with it. All right, all the graduate cylinders at the bottom. Mark out B. We're only doing A and C. So the graduate cylinders at the bottom, mark out B. We're only doing A and C. And on the back, we're only doing A and C. So you're doing 3 scales, 3 triple B balances on the front, and then you're doing A and C on the front and A and C on the back. Everybody got it? A and C. Yeah, measure units. Measure units. Okay? So if we get to the lab today, if you forget a unit on any of your 7 things you measure, I do what? So look back at your answers you wrote down. If you get to have a doubling units on things, you will forget on the time to collect also. So what unit would go on the scale? What unit do you think we're going to put on that? Right, kilogram sheet. It might be the SI. So these grams, what's going to go on the graduate summary? Milliliters. And what's going to go on the thermometer? Degree Celsius. Kelvin voltage. All right, everybody have a chance to try them all? All right, so if we look at the first triple big balance up here. All right, sometimes people struggle with the graphics on these because the scales really are kind of ugly. All right, but if we look at what you have up here, what's the middle beam trying to illustrate? 600. All right, what's the top beam illustrating? 20. All right, so 600, 20. And then the bottom one, I give you a lot of leeway here. So what do you think it looks like? 2. All right, 622 point. All right, 9. All right, and what's your guess? All right. Did anybody say 622.8? Okay, and what's your guess? Okay, I get those two a lot. All right, did anybody say 622 or 623.0? So it was on the 3 line. If you say it's there, exactly on the 623 line, I don't think it really is, but some people tell me it looks like it's exactly on that line right there. 623 has no tenths. All right, what's the guess got to be if it's exactly on the line? Can you just not put a guess? Got to have a guess. You put a 0 there if you think it's exactly on the line. Okay, any of those would be okay. Okay, that one is the only one that's just truly terrible. The rest of them we should be able to do. All right, so number 2, what's the middle beam? Top beam? The bottom? Point? All right, what's your guess? I think it looks pretty much on the line too. I would go with 0. Now, if you don't have it on the line, what's your guess? All right, 153.69 is good. I would be fine with that. Anybody have something different? 71 would be fine also. All right, number 3. What do you have for the first one? Top, point, or sorry, bottom one, point. I think it looks like 5, 2, and then I hear 2, I hear 3. Okay, I heard a 5, I heard a 1. Again, it's your guess, so any of those are fine. As long as you're in the 200.5 range and you have a number behind it, it is acceptable. Okay, are we okay with how to read the scale? Now, tell me this. What do you notice about the number of places behind the mass? What do you notice about the number of places behind the decimal in a mass? It has how many? That's 2. Okay, so when you read today or tomorrow on the triple beam balance, how many places should be behind the decimal? Okay. All right, so from there, the graduated cylinder, or A. Remember, this one is one we don't have in the room. All right, what can you tell me about this one? All right, so you're saying it's 56 point, because you get a guess, because this reads the ones place, you get a guess. All right, 66.0 is fine. 55.9 is fine. 56.1 is fine. See how there's some leeway in reading these? As long as you have the guess, you're fine. Okay, milliliters, milliliters, milliliters. You don't all see it the same way. All right, and the last one, what do you see here? 23. Okay, 0.7. I heard 0.9. I heard 0.8. All of those are fine. All right, everybody good? All right, the two for the thermometer. All right, I said A and C. So, A, what do you think? All right, I hear 68. All right, what's my guess? 0.0, 0.1. Anybody go with 67.9? No? Okay. And the last one, C. All right, so 11 point. Okay. Anybody go higher or lower? 0.1? Okay, any of those would be fine. What units are we putting on these? Degrees Celsius. All of these should be degrees C. All right, questions about how to do that if you're asked to do that today? All right, it depends on how the next part goes if we get there. All right, let's talk rules for significant digits. Okay? Now, we're going to use these rules tomorrow to calculate. You remember Friday, we were doing some things, and you guys kept going this wall. Do you want us to round the one place behind the desk or two places? Well, this is going to begin to lead us to how to calculate tomorrow. Because tomorrow, we're going to learn to calculate with significant digits, so we'll know how to round. Okay? That's where we're going with this, is being able to round. There we go. So, we're going to talk about 6 rules. A minute. For significant digits. And you have a quiz on these tomorrow. And I know that's a quick turnaround. But this is not hard. Okay? These are pretty easy. Number 1. All non-zero digits are significant. Now, what do I mean by non-zero digits? So give me an example. Okay, so you mean any number that's, give me a simpler example. 9, 1. Yes, that's what I'm looking for. Any number 1 through 9. Okay? So all non-zero digits are any numbers between 1 and 9. So if you have a number, and I'm going to use Samaria's number, what do you say? 231.37. Okay? How many significant digits are in Samaria's number? Is that significant? Yes. Is that one? Is that one? Is that one? Is that one? So how many significant digits are there? There are 5. Okay? Now, they might not all be that large. You might have a number like 427. How many significant digits are there? There are 3. Because they are all non-zero, they are significant. So, what are the other 5 rules about? If I just covered every number 1 through 9 in rule 1, what's the only other number left? So the other 5 rules are about digits. Okay? Now, rule 2 is the next easiest. All zeros between non-zero digits are significant. If the 0 is between the non-zero digits, it is significant. So, if we have a number like 4,004, where are the zeros at? They're in the middle. They're between the 2 4s. Therefore, they are what? So, there would be 4 significant numbers here. Now, in a minute, the remaining 4 rules are going to add in some decimals. So, let's just say I have a decimal here. Does the decimal have any impact on that rule? What are shaking his head no, and he is correct. The answer is no. The zeros are still where? In the middle. They're still between the 5. So there are still significant, and there are still 4 significant numbers here. Okay? Those zeros are still significant because they're between the 2 5s. Are you with me on rule 1 and rule 2? If you're not with me on those 2, you're dead in the water. Okay? All right. Rule 3. All zeros to the right, all zeros to the right of a non-zero digit and the left of an understood decimal point are not significant. Right? All zeros to the right of a non-zero digit and the left of an understood decimal point are not significant. So, if I have a number like 450, where is the decimal at? After the zero. Okay? You guys have learned there's a decimal there since best guess 2nd grade. Okay? We all know this. Since there is an understood decimal point, that means that zero is not significant. So there are only 2 significant numbers there. Okay? Because it's understood. Now, if I write the decimal and I do that, then how many significant digits are there? Now there are 3. Right? The reason that 0 is not significant is we assume that the number has been what? Rounded off. Okay? And if we write the decimal in, we assume that we measured it to that decimal place. But if we do this, we assume it's been rounded and it's not significant. Okay? That's the reason for it. So if it's an understood decimal and it's not written, it's not significant. If it's written there, it is significant. Okay? Everybody with me? Okay. Number 4. In numbers less than 1. Okay, now we're going to do some 0.0. Okay, in numbers less than 1, the 0 to the left of the decimal point is not significant. In numbers less than 1, the 0 to the left of the decimal point is not significant. So, something like 0.15. We're talking about that 0 right there. All right? What's that zero's function? Because a lot of you would just write 0.15 and wouldn't include that 0. So, what's its function? Why is it there? Yeah. What else? What? Not so much. Any other reason? I mean, if that and this is the same number, why write it at all? Why waste our time? It's a billboard, okay? It's a sign. Its only function is to say, hey, there's a decimal behind me, pay attention, okay? So when I type the test, if it doesn't make a really good copy on the copy machine, would you notice the decimal if it was a bad copy? Maybe, maybe not. You might just notice it's a 15 and not a 0.15. But if I put the 0 there, are you going to notice that it's a 0.15? Most likely, okay? So, since that's just a billboard, that's going to be 2 significant digits, okay? This one is our billboard rule. Okay, that's its only function, to serve as a billboard. All right, now this one is the one you've been hearing about. Best guess is third grade. In numbers less than 1 again. The zeros to the left of the non-zero digits, but the right of a decimal are not significant. They are placeholders. Now, we've been talking about placeholders in math class for years. Okay? Placeholders are not significant. Placeholders are not significant. So in numbers less than 1, the zeros to the left of the non-zero digit, but the right of a decimal are not significant. They are placeholders. All right, are caught up? So, if you have a number like 0.00017, all right, these are the zeros I'm talking about. Those zeros are placeholders. They don't do anything but hold the place of the 1 and the 7. So how many significant digits would I have here? I would only have 2, because this 0 is a what? The billboard. It's like, hey, there's a decimal behind me. So this only has 2 significant digits. Now, how many do I have there? Why? Why? Because what rule? It's between the 2. That's correct. So therefore, these 2 are between, which makes them significant. These are not because they're placeholders, and that was the billboard. All right, last rule. All right, and I'm never going to ask you the rule number. Okay, I'm not going to ask you rule 1, rule 2, rule 3, but you do need to be able to explain. All right, the last rule, all zeros to the right of a decimal and a non-zero digit are significant. All zeros to the right of a decimal and a non-zero digit are significant. All right. So if you have a number like 65.00, all right, these numbers are to the right of the decimal. All All right, these numbers are to the right of the decimal and to the right of the 5. Okay, they're essentially after the decimal. All right, they're behind the decimal. And because they are, they're significant. All right, everybody with me on that? Yes? Think you can try some? Okay. All right. I want you to determine the number of significant digits in those ones or not. I would, but they're your notes. It doesn't matter to me. I'm not collecting it. Put that way. Have a question? All right, and number 1. Okay, how many just wrote that? Here's the right answer. Any questions about number 1? Number 2, how many just come up with 4 is the right answer? Questions about number 2? And you just look at the other way, so you just get up off the desk and just like, okay. About 3, Marissa. This is the right answer. Question. All right, number 4, Celia. This is the right answer. Question. All right, number 5, Ashanta. Huh? Almost. Which zero do you think you missed? That is? All right, this zero is what? That's out. These are, so they're out. These are, so those you're good with. Why do you suppose this one would be significant? Any ideas? Anybody want to help her? Say it. It's to the right of the decimal and to the right of the 4. This is rule 6, behind both. So there are 3 significant digits there. It's after both of them. Got it? All right, number 6. How about Darlene? 4 is the right answer. Questions about that? All right, how about 7? Karen. What about those zeros? I suppose I'm thinking about those zeros. There's 5. Any idea why? Other than I'm questioning you? The exact same rule that Ashanta missed. They're behind the 5 and they're behind the decimal. Same rule. All right, how about number 8? Stephanie. It was the right answer. Why are those zeros not significant where the other ones are significant? They're what? With or without? That's right. It's an understood decimal. There's no decimal written, which is why those are not significant. Does that make sense? Okay. And the last one, number 9. How about Andy? 7 is the right answer. Questions about that? No? Everybody's good. All right. Now let's see. Probably done this in another class. We should be shocking to y'all. All right. Y'all played clickers before? Great. There's a lot in here. You only have 20. I'm going to do about 4. I need to talk about homework. Let's close the finish. Yes. Homework on. Now, the back side of your homework, don't mess with it. We talked about how to calculate the significant. No, find save the paper. Find your charge. Real quick. Find your name, find your charge. All right, everybody's not played this. Okay. Eventually you have a card game. Okay? All right, so the answers are A, B, C, or D answers. Okay, so I'm going to borrow Sophie's card. So there are letters of A, B, C, and D on everybody's card. Okay, they're done this way so that essentially, remember playing four corners, people would put A, B, C, D in the corner, and it didn't take y'all long to figure out to follow the slot push to the class to the right corner in the room. This is to eliminate that. Okay, so let's say that when I put the question on the board, Sophie's like, okay, the answer's A. So Sophie finds A on the card, and she holds A up. Okay, so she rotates her card so A is up. If she wants her answer to be B, she turns her card so B is pointing up. Okay? She wants D, D is pointing up. Okay? Does that make sense? And everybody's little shape is a different shape. Okay? That way, Tiffany can't look at Darlene or Abraham. Sophie can't look at Jake. Or Sophie's a spot. But Tomas can't look at everybody around him and pick. He can't sure that everybody else has around. That's the reason for players. But also, remember the little remote we all had when we were all fighting to get near the blue bowl? You get our answers in first. Okay, it eliminates all of that, the batteries and the rest of it. You have a card. I scan with either my phone or my iPad on them. My iPad is bigger, and I can see the data. Okay? All right. So, I don't need to have the panel. And that's that. Hold it up. And then I scan. Now, if your hand is on the black, it will not scan. Keep the thumbs out of the black. All right, so we got 16 rights, 3 wrongs. Is there a decimal point in the answer? No. So it's understood decimal point, which means the 2 zeros are not significant. There's only 2. Okay? How many significant digits in that number? I forgot my question. Question mark. Until I just how many significant digits in that one? Okay. So 17 people have a right and we have 1 wrong. There is 5 for a right answer. All right. And 1 more. Last one. All right. So we got 13 right and 6 wrong. All right. So when we look at this one, this is a decimal, right? Doesn't matter. These 3 are in between the 5 and the 3. they're automatically significant. That takes care of 6. And this one is after the decimal and after the 3. So there are 7 in that answer. Any questions? All right. Stay put for just a second. Hand out the papers. We'll all jump over using your calculators and your own. Now, we are only doing the front. I will tell you which numbers we're doing in a second. So, now, on the back, we have not learned how to add, subtract, multiply, or divide, leave it be. So, look at the front, where it says question number 1, round to 2 significant digits. If you got 5.463, what are the first 2 significant digits? The 5 and the 4. If you're rounded to 2 significant digits, it should be 5 point what? This should do what? You should make it 5.4. Although I'll tell you, I'm real lenient. If you left it at 5.4, I am perfectly content because you have 2 significant digits. I will take the answer either way. Okay? We're doing 1 through 20 at the top. Okay, 1 through 20. You're just telling me how many significant digits. In the bottom, you're doing the odd in the middle and odd at the bottom. Okay? So 1 through 20 at the top, odd in 1 through 10, odd in 1 through 10. Bring me my flicker cards or put your calculators up, please. If you need help, I will be here this afternoon. Your quiz tomorrow is on what? Significant numbers. Very good. I'd love to tell you later today. We will see. Have a good rest of your day. Get your contact fixed.
Yeah.
Good.
I had to watch your video. That was confusing.
I need one more calculator over there. Where's the last calculator? There it is.
Okay.